the and the different types of sets we have discussed, and the property of sets we have discussed. Right? Now let me introduce the notion of relation. Relation means you take any two sets. Let us start with any two sets. First, you need to know, in order to define a relation, first you need to know that Cartesian product. You know what I mean by Cartesian product? A cross B is nothing but a Cartesian product. Means what? Set of all order pairs such that A belongs to A and B belongs to B. Is nothing but what? Cartesian product. Cartesian product of A and B. Right? This is what my first component. This is nothing but what? Second component. So A cross B is nothing but what? Set of all order pairs. That means, for example, you can take A equals to 1, 2. Suppose you can take B equals to AB. What is my A cross B? A cross B is nothing but what? 1 comma A. First element is coming from A, second element is coming from B. So next 1 comma B. Next 2 comma A, 2 comma B. Right? This is nothing but A. This is A. My set B is nothing but what? A comma B. 1 comma A, 1 comma B, 2 comma A, 2 comma B. This is nothing but my A cross B. Right? Now what is meant by relation? So we say that R is a relation. R is the relation from A to B. If and only if just it's a subset of A cross B, that's it. If it is a subset of A cross B, automatically that R is a relation from A to B. Right? Suppose, for instance, you take this example. Just continuing this example. My R1 is equals to, my R is equals to, suppose 1A or 2A. Is it a relation from A to B? What is my R? My R is not. This is my A. This 1, 2. This is AB. What is my R? My R is 1 goes to A. Next 2 goes to A. Right? So question is it a relation? Yes, because it is a subset of A cross B. Right? Therefore, R is a relation. R is a relation from A to B. Right? Once you define a relation, we say that different types of relations. Suppose you take this R1 is equals to, suppose we can take let X A, Y B. Is it a relation from A to B?
No.
No. Because it's not a subset of A cross B, therefore it's not a relation. Right? So this is nothing but about the relation. Next, we discuss about the types of relations. Before types of relation, first you need to know the number of relations formula, counting formula. Notice the cardinality of A is M, cardinality of B is N. What is the cardinality of A cross B?
M cross N.
M into N. That's it. Cardinality of A into cardinality of B. Right? Now question is number of relations.
Number of relations.
2 power of mn.
2 to the power of m into n.
From A
Power
to B.
mn.
Mn. Right? So that is nothing but what? 2 into 2 power mn. That means what? You take any relation, it must be a subset of A cross B. Any relation that you started with. You take any relation that you started from A to B. Right? From A to B, that must be a subset of A cross B. So in order to find a relation, it's enough to find a subset of A cross B, right? In order to find a relation from A to B, it's enough to find a subset of A cross B. So how many subsets of A cross B? Just 2 power mn, right? Because there's how many elements in A cross B? Number of elements in A cross B is mn. Therefore, total number of subsets of the set which is containing mn elements is nothing but 2 power mn. Therefore, number of relations from A to B is nothing but what? 2 power m. Right? That's what actually idea. So to find a relation, it's enough to find a subsets of A cross B. You know, A cross B contains mn elements. Automatically, that number of subsets which containing mn elements is nothing but what? 2 power mn. So this is nothing but cardinality of the relations. Means cardinality of the A cross B and the number of relations from A to B. Right? And let us discuss about types of relations. First is void relation. First one is what? Void relation means empty relation. Means what? Empty set is always a subset of any A cross B. Therefore, it's a relation from A to B. So empty set is always is nothing but a relation, which we call it as void relation or empty relation. Next is universal relation. Next is what? Universal relation. So what is universal relation? A cross B itself is a universal relation because the total number of order pairs is nothing but what? Is a relation because it's a subset of A cross B. A cross B itself is a subset of A cross B. Therefore, itself is a relation. This relation we call it as a universal relation, which we call it as what? Universal relation from A to B. Right? These are very standard relations. Right? Next is what? Identity relation. What is identity relation? You take any sets?
A cross A.
Yeah, that's it. Not A cross A, set of all order pairs of the form A comma A such that A belongs to A. It's nothing but what? Identity relation.
Identity relation.
Right? A goes to A itself. A goes to A itself. It's nothing but what? A goes to A itself. It's nothing but what? Identity relation. So this is what actually about a number of relations from A to B. Suppose you want to define a relation on a set. Relation on a set. You take any set. What do you mean by relation on a set? Look at A cross A. If any set which is subset of any set which is subset of A cross A, therefore automatically R is a relation on A. R is a relation from A to A. That is same as saying that R is a relation on set A. This is what actually relation on a set. For example, you start with any set, for example, A equals to 1, 2. What is my A cross A? My A cross A is 1, 1, 1, 2, 2, 1, 2, 2. This is nothing but set of all order pairs from A to A. Now take any R, any subset. Take any subset, 1, 1, 1, 2. Is always subset of A cross A. Therefore, R is a relation. R is a relation on a set A. Right? Any subset of A cross A is nothing but one relation on a set A. Right? Any subset that you consider from subset of the A cross A is nothing but one relation from A to A, or else relation on a set A. Right? Suppose you take this. Suppose R is equals to on the same set 1, 1. Suppose 2, 3. Is it a relation on a set A?
No, sir.
No, because it's not a subset of A cross A, therefore not a relation on a set A. Right? Next is, so relation on a set, there are so many types of relation on a set, standard relations. So first one is types of relations. What are the types of relations on a set? First one is reflexive relation. What do you mean by reflexive relation? Take a set. What do you mean reflexive? Any set, any element that is related to itself. Any element that is related to itself. If that happens, that is nothing but, if that happens, we say that R is reflexive. Understand? Any element that is related to itself, automatically that relation is nothing but what? What is my R? R is a relation first on a set A. R is a relation on a set A, and any element that is related to itself, automatically one can say that R is reflexive on A. For example, you can take this. A is equals to 1 to same example that you started with. A cross A is nothing but what? 1, 1, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2. For example, I consider this 1, 1, 1, 2. Is it reflexive relation? Is it reflexive relation?
No,
right?
sir. 2 2 not covered. No.
Right?
No.
What is my definition? Any element that is related to itself. But for 2 is not related to 2 itself. Therefore, it is not reflexive on a set A. Right? It's not reflexive. Suppose you take this, A is equal to same set. Suppose R is equals to 1, 1, 2, 2. Is it reflexive?
Yes, sir, it is.
Yes, because 1 is related to 1 and 2 is related to 2. Suppose R is equals to 1, 1, 2, 2. Suppose 1, 2. Is it reflexive?
Yes, sir.
Yes. I don't bother about 1, 2. What I bother, just any element that is related to itself or not. If you know this, any element that is related to itself, it's enough to show that, it's enough to say that R is a reflexive on a set A. I don't bother about 1, 2 or 2, 1 something else. What I require, any element that is related to itself or not. If that happens, that is a reflexive relation. Sorry, on a set A. Right? Suppose you take this. So next is counting argument. So before counting, first you need to know that different types of relation. This next is symmetry relation. Symmetric asymmetric relation. What is symmetric?
A relation B, B relation A.
Yeah, A is my set. We take any relation. R is a relation on a set A. Then R is symmetric on a set A if and only if A is related to B for any two elements A comma B belongs to A, automatically B related to A. If that happens, this R is symmetric. Right? If A is related to B, automatically B related to A must be there in R. Example, you take A equals to 1, 2. As I said, what is my A plus A? 1, 1, 1, 2, 2, 1, 2, 2. Right? Suppose R is equals to this 1, 1, 1, 1, 2. Is it symmetric?
No.
No,
Sir.
right?
No.
1 related to 2 is there, but 2 related to 2 now is not related to
1 is not
there. Therefore, it's not symmetric. Suppose if I take this, R is equals to 1, 1. Is it symmetric?
Yes, sir.
Yes, sir.
Yes. Right? Suppose you take 1, 1, 2, 2. Is it symmetric?
Yes,
Yes, sir.
sir.
Yes. Yes, right?
Yes, sir.
Suppose if you take R is equals to 1, 1, 2, 2, it's 2, 1.
No, not symmetric.
No, sir.
No, right? 2 automatically B must be related to A is there. Right? This is what actually symmetric. Right? Next is transitive. Right? You take any set, you take R is a relation and a set A. We say that R is transitive and a set A if and only if A is related to B and B is related to C is there, definitely A must be related to C is there. This is true for any three elements. If A related to B is there, B related to C is there, we need to show that A is related to C is there. If A is related to C is there, automatically this is transitive relation. For the same example, why I'm taking same example? Because it's for simplicity, for understanding purpose. So 1 2 2 1 and 2 2 like this, right? Suppose R is equals to, suppose you take this 1 1 1 2. Is it transitive? Yes, right? 1 is related to 1 is there, and 1 is related to 2 is there, and that will imply that 1 is related to 2 also there. Yes or no?
Yes, sir.
Therefore, it is symmetric. Suppose R is equals to 1 1. Is it transitive? Sorry, is it transitive? Yes.
Yes, sir.
Yes.
Right? Right? Suppose you take this. My A set is, suppose you can take natural numbers, right? Suppose R is my relation. R is defined by like this. A is related to B if and only if this A is less than or equals to B. For A comma B belongs to A means natural numbers. What is my A? My A is natural numbers. So question is it reflexive? Is it reflexive?
Yes.
Yes.
No.
Any element that element is always less than or equal to itself, right? Suppose you take 1,
Yes, sir.
it is always less than or equal to 1. Suppose you take 2, 2 is less than or equal to 2, right? So any element that is less than or equal to itself, this is true for every natural number. So whenever A is less than or equal to B, so what is my definition? A must be related to A. This is true for every natural number. Therefore, any element that is related to itself, therefore R is reflexive on natural numbers. Question is it symmetric?
No, sir.
So if you say no, so give a counter. You need to provide A is related to B. You need to provide two elements in such a way that A related to B, but B is not related to A. I can take A equals to 1, B equals to 2. So automatically 1 is less than or equals to 2. Therefore 1 is related to 2 itself. Whenever 1 less than or equals to 2, whenever 1 less than or equals to 2, we can write it as A1 is related to 2. But the thing is, 2 cannot be less than or equals to 1. Yes or no? 2 cannot be less than or equals to 1. Therefore 2 is not related to 1. So therefore 1 is to 1 related to 2 is there, but 2 is not related to 1. 2 is not related to 1. Therefore it's not symmetric. Question is it transitive?
Yes, sir.
Give me 3 elements. If you take A is related to B and B is related to C, so A is related to B means what? A is less than or equals to B. What is B related to C? B less than or equals to C. Therefore A must be less than or equals to C. Therefore A must be related to C is there. Right? So therefore it is transitive. And I said C. Right? Suppose we take another example. Suppose A is my natural numbers. Right? A is related to B. If and only if A divides B. Yeah. First one, is it reflexive?
Yes, sir.
Yes, sir.
You give me 1. If you give me 1 divides automatically 1. So 1 is related to 1 itself. If you give me 2 divides automatically to itself. Therefore 2 is related to 2 itself. So therefore any natural number that is related to itself. So it is reflexive. Question is it symmetric?
No, sir.
Suppose 1 A equals to 1 you take, B equals to 2 you can take. Automatically 1 divides 2 is there. So what is meant by 1? A divides 2 B, A divides B is there. But the thing is, unfortunately, 2 does not divide 1. Therefore, 1 divides 2 is there, but 2 does not divide 1. Therefore, A related to B is there, B is not related to A. Therefore, not symmetric.
Metric.
So is it transitive?
Yes, sir. Transitive.
Suppose we take any 2, 3 natural numbers.
बिस्किट खाने को दहना
A divides B is there. Take B divides C is there.
इडली है दाल लिखा
While A divides B is there, B divides C is there. So what is meant by A divides B? So therefore, automatically A divides B is there, B divides C is there. Automatically, what is this? B equals to AQ1 for some integer, positive integer. Right? What is meant by B divides C? C is equals to some BQ2 is there for some positive integer. Yeah. So what is this? C is equals to substitute B value in this equation. What do you get? AQ1 into Q2. Therefore, this can be written as A into Q1 Q2. Therefore, C is equals to AQ1 Q2. Therefore, what does it mean by this? A divides C. So therefore, whenever A divides B, B divides C, automatically A divides C by division algorithm. Right? So therefore, it is transitive. Therefore, it is transitive. So it is reflexive, but not antisymmetry, not symmetry, but it's transitive. Right? Suppose you take this example. Here is my integers. Take any positive integer. Means it's a natural number. A is related to B if and only if M divides A minus B or B minus A. You can take anything. So this is a very important relation in group theory, by which we can define an equivalence relation, equivalence class of that integer that we call it as what? Equivalence class of 0, equivalence class of 1, by which you can define Zn, you know Zn, class of equivalence classes, set of all equivalence classes. So this is what actually equivalence relation, by which you can define a equivalence relation. So this is what actually important relation. Question is it reflexive?
Yes, sir.
What is makes sense? You give me any integer. You give me any integer. So this positive integer always divides 0, right? Any positive integer divides 0, right? Yes or no? Yes, right? Any positive integer divides 0.
Yes, sir.
Positive integer divides
Yes,
0.
sir.
But 0 can be written as A. 0 can be written as A minus A. Therefore, A minus M divides A minus A. Therefore, A is related to A by definition. By definition. Therefore, it's reflexive because A is related to A. This is true for every A belongs to A. Question is it symmetric? Suppose A related B is there. What do I mean by this? M
Yes, sir.
divides A. What do you mean by M divides A minus B? M is equals to Q for some integer. What do I mean by this? Into multiply with minus, what do you get? M into minus Q. Whenever Q is integer, minus Q also integer because it's an integral domain. So automatically group, with respect to addition and multiplication, it's an integral domain. Therefore, B minus Q is equals to M into minus Q. Therefore, whenever this happens, whenever something M and M, M divides Q, M divides A minus B means what? This, what do I mean by this? So B divides M divides B minus A. So therefore, M divides B minus A means what? By definition, B related to A. So we start the proof by taking A is related to B. We end up with that, B is related to A. This is true for any two elements that you consider in integers. Right? Therefore, it is symmetric. So what is meant by transitive? This is also redundant. This is also redundant. We take A is related to B, B is related to C. Automatically, what does mean by this? M divides A minus B. Similarly, what is this? M divides B minus C. What does mean by this? A minus B equals to M into Q1 for some integer. B minus C is equals to M into Q2 for some integer. Therefore, just you add them these two equations. What do you get? A minus B plus B minus C is equals to M into Q1 plus Q2. But the BB cancel. A minus C is equals to M into Q1 plus Q2. Therefore, A minus Q can be written as some M into some integer. Therefore, M divides A minus C. Whenever this happens, is related to C. So from which all cases, what you observe? It's what it is reflexive, symmetric, and transitive. Right? So if the relation satisfying these three relations, automatically that relation is an equivalence relation.
సార్ ఒకసారి మళ్ళీ పైదాన్ని క్లియర్ గా ఎక్స్ప్లెయిన్ చేయండి సార్ ఫాస్ట్ అయిన త్రీ ప్రాపర్టీస్
Which one?
ఆ ప్రాపర్టీస్ ఈక్వివాలెన్స్ రిలేషన్స్
Yeah, these three examples, three cases. These three cases,
యా సార్ కొంచెం తెలుగులో కూడా అప్పుడప్పుడు తెలుగు కూడా వాడండి సార్.
ఎస్ సార్ 3 cases.
సార్ రిఫ్లెక్టివ్ ట్రాన్సిటివ్ ఉన్నాయి కదా సార్, ఆ రిలేషన్స్ అది ప్రాపర్టీస్ ఒక్కసారి అట్లా తెలుగులో కొంచెం చెప్పండి సార్. తెలుగు ఇంగ్లీష్ కంబైన్ గా వాడండి సార్.
ఓకే ఓకే ఓకే. సి m అనే 0 డివైడ్ చేస్తుందా కదా. ఫస్ట్ రిఫ్లెక్సివ్ అంటే ఏంటి? రిఫ్లెక్సివ్ మీన్స్ ఎనీ ఎలిమెంట్ దట్ ఈస్ రిలేటెడ్ టు ఇట్ సెల్ఫ్.
పరివర్తనం.
అంటే తెలుగులో
నో సార్, తెలుగు పదాలు కష్టం సార్, తెలుగు వర్డ్స్ వాడొద్దు, బస్ ఎక్స్ప్లెనేషన్ తెలుగు అంతే.
రిలేషన్ అని అంటే చాలు సార్, అవసరం లేదు అంత.
ఏ ఎలిమెంట్ దాంతోనే రిలేటెడ్ కావాలి, కంపల్సరీ ఉండాలి. ప్రతి ఎలిమెంట్ కి రిలేషన్ ఉండాలి, దాంతోనే ఉండాలి, వేరే దాంతో అవసరం లేదు. ఉన్నా లేకుండా మనకు సంబంధం లేదు, కానీ ఏ ఎలిమెంట్ అయినా దాంతో కంపల్సరీ రిలేషన్ ఉండాలి. రిలేషన్ అనేది we say that R is equivalence relation.
Sir, will you please give me total definition of this symmetric and transitive and relative? Sir, I think we understood this concept, sir, but total definition we need, sir.
Written already. Go back to your slides.
Yeah, of course.
Right. So therefore, R is reflexive. Right. R is reflexive. What is reflexive? Any element that is related to itself. Next is R is symmetric. On A. What am I saying? Symmetric? A related to B when you consider B must be related to B. Right? By notation. And third one, R is transitive. On A. That means what? Whenever A related to B, B related to C is there, you need to prove that A related to C. This is true for any three elements. If that happens, that means R is equivalence relation means if and only R must be reflexive on A, R must be symmetric on A, R must be transitive on A. Therefore, if R is satisfies the three relations, we can say that R is equivalence relation. Right? Suppose let us consider we can take any set. You can take any set. Suppose you take, for example, X is any set that you started with. You can take a power set of X. My relation is here A is related to B if and only A is contained to B. A is contained in B. Right? First, A comma B belongs to power set. A comma B belongs to power set. Right? Question is it actually reflexive or not? So automatically
Reflexive, sir.
reflexive.
Every element is subset to itself.
Yeah, take any set, any member in a power set, automatically by definition, A is related to A is subset of itself. నేను చెప్పాను ఆల్రెడీ ఎస్టర్డే క్లాసెస్ లో ఏ సెట్ అయినా ఏ సెట్ అది కదే సబ్సెట్ అయిపోతుంది. సో ఏ సబ్సెట్ ఆఫ్ ఇట్సెల్ఫ్ కాబట్టి బై డెఫినేషన్ వెనెవర్ ఏ సబ్సెట్ బి అయితే ఏమని రాయొచ్చు, ఏ రిలేటెడ్ టు బి అని రాయొచ్చు. ఇక్కడ ఏ సబ్సెట్ ఏ ఉంది కాబట్టి ఏమని రాయొచ్చు, ఏ రిలేటెడ్ టు అని రాయొచ్చు. This is true for any element, not only single element, because it's an arbitrary. Therefore, any element that is related to itself, therefore it is reflexive. So this relation is very, very important when you go through the group theory and mathematical analysis, function analysis, because this by which we can prove that it's you can use Jones lemma by which you can prove that every inner product space is an orthonormal basis, orthogonal basis. So this is what actually very, very important relation. Question is it symmetric? Suppose
not symmetric.
Need not be symmetric. Suppose you take X is equals to this. What is my power set? Empty. Singletons 1 2. So I can take A equals to what you take actually 1 1. What is my B? B equals to 1 2. So already you know that A is subset B, yes or no? Because A is my set singleton. B is equals to 1 2. So therefore clearly A subset B. Question is it B subset A? Is it true?
No, sir.
No, sir.
Not true. No, sir.
So A subset B means A must be related to B. So here B is not subset A means B is not related to A. So here A subset B is there, but B is not subset A is there. Therefore it is not symmetric. It's not symmetric. Not symmetric. On power set. Question is it transitive?
No, sir, it is not. It is transitive. Yes.
You take any three elements that you started with. How many elements to prove transitive?
3
How
elements.
many elements required?
3 elements.
You need to take 3 elements,
3
right? So you take that A subset. A is related to B. You need to take that. Japan A is related to B and this call B related to C and this call. Mere this call. So A subset A related to B and A subset B. B related to C and B subset C. A subset B subset C and A subset. A subset means A is related to C. So therefore, when you A related to B and B is related to C, automatically it will happen that A is related to C. This is true for any three element that is appeared in the power set. So therefore, it is transitive. So reflexive symmetric got ledu transitive. Equivalence side the
No,
transitive
sir.
got reflexive symmetric got ledu. Either no fail అయితే కాదు కదా equivalence. On the process. Okay. Suppose you can take another example. A is equals to integers. What is my A? My A is integers. Suppose A is related to B. Only A less than or equals to B. Is it equivalence relation?
Yes, sir.
First check the reflex rate.
No,
No,
symmetric.
Not symmetric.
Not symmetric.
Yeah, 1 related to 1, 2 related to. Therefore, any element that is related to itself. Therefore, it is
Reflexive.
Question is symmetric either.
No, sir.
Suppose I take 1 related to 2 automatically because 1 less than or equals to
Yes,
1. Question is 2 less than or equals 1 either.
No, sir.
No, sir.
Therefore, that will imply that 2 is not related to
2
1.
is not related to 1.
Therefore, it is not symmetric. Next, symmetric కాలేదంటే equivalence relation కాదు. అంతే కదా, not equivalence. ఇక చెక్ చేయాల్సిన అవసరం లేదు, నాట్ ఈక్వలెన్స్ రిలేషన్. ఒకటి ఫెయిల్ అయితే చాలు కదా, ఎనఫ్. రైట్, నెక్స్ట్ ఈస్ suppose you take a plane, a two-dimensional plane. Suppose L1 is my line, L2 is my another line. L1 is related to L2 itself. Therefore, L1 is parallel to L2 for any two lines which are appeared in a plane. So what is my set? My set is a plane. Question is it reflexive?
Yes, sir.
Yes, sir.
What is my condition actually? When you want to say that two elements are related, we say that two elements are related if only
Parallel
the
to
two
each
elements
other.
are parallel. These two elements are related. What is the condition between them? Parallel.
L1 is parallel to L2, L2 is parallel to L2.
So any line that you take that is parallel to itself.
Transitive.
So therefore, L is
It is
related to
reflective.
this is for any line which is in the plane. Therefore, it is reflexive. Is it parallel? Is it symmetric? Yes.
Yes,
So
sir.
take L is related to M. When you take L is related to M, automatically M is related to
L.
L. So symmetric. Is it transitive?
Yes,
Yes,
sir.
sir.
Whenever L is parallel to M and M is parallel to N,
Then L is parallel to L.
L is parallel to L.
it is transitive. Therefore, it is equivalence relation.
So it is the
What about the perpendicular relation? You take a plane. L1 is related to L2 if and only if they are
perpendicular
perpendicular to it.
Not equivalent.
Sir, it is not reflexive.
Not.
You chart box.
Which chart box? Use the mobiles.
1 minute. Use your answer in chat box, all of them.
So which of the following is true? First one, reflexive. Which one answer is right? Second one is symmetric.
Not transitive also.
Transitive. Fourth one is equivalence relation. Which one is right?
B is correct. It is symmetric.
Okay. So chat box లో రాస్తున్నారా?
సార్ వాళ్ళందరూ నాకు పెడుతున్నారు డైరెక్ట్, నాకు డైరెక్ట్ పెడుతున్నారు, అలా కాకుండా ఎవరివన్ అని పెట్టండి. సో నాట్ రిఫ్లెక్సివ్, సిమెట్రిక్, నాట్ ట్రాన్సిటివ్. స్టార్ చూస్తే నాకు పెట్టవకండి, సార్ పెట్టేసి ఎవరివన్
ఆప్షన్.
everyone కి వస్తలేదు సార్, ఓన్లీ host and co-host కి వస్తుంది.
Okay. So any element that you take is always line. Any line itself parallel to itself, but it cannot be perpendicular to itself. So therefore, a line which cannot be perpendicular to L, so therefore L cannot be related to itself, right? Therefore, it is not reflexive, because any line is parallel to itself but cannot be perpendicular to itself. Therefore, a line which cannot be related to itself, therefore it's not reflexive. Is it symmetric?
Yes, sir. It is symmetric.
L is parallel to M. Automatically, suppose L is perpendicular to M. Automatically, M is perpendicular to L. So therefore, whenever L is related to M, automatically M is related to L, because both are 90 degrees. Right? So therefore, it is symmetric.
Not transitive.
Is it transitive? Suppose
No,
L is
sir.
perpendicular to L,
No, sir.
M is perpendicular to N. So, by corresponding angles axiom, this 90 degrees, this is also 90 degrees, corresponding angles axioms, automatically this L is perpendicular, L is parallel to N. This L is parallel to N. So cannot be perpendicular to. So L is perpendicular to M and M is perpendicular to N, okay. But the thing is, by corresponding angles axiom, L is parallel to N. So L cannot be perpendicular to N. Therefore, it is symmetric, okay, but not transitive. Suppose we take this. Next, A comma B is related to C comma D. If and only AD B plus C is equals to BC A plus D for any face in E. Question is it reflexive? Use chat box. Use chat box. Is it reflexive? So to show
Yes,
A
sir.
is related to A comma B, to show
Yes,
A
sir, it
comma
is
B
reflexive.
related to A comma B, you need to show that A into B, A into B, B plus A is equals to BA into A plus B. Is it possible? Yes, because AB B plus A is same as saying that BA plus B, right? Right? So therefore, it is reflexive.
Reflexive.
Right? So therefore, it is reflexive. Right? Because AB into B plus A is same as saying that BA plus A, BA into A plus B. So therefore, it is reflexive. Question is it symmetric?
Yes, sir.
Yes, sir.
Check.
It's not symmetric. Not symmetric.
So AD, whenever A comma B is related to C comma D, AD B plus C is equals to BC A plus D, right? But this can be written as BC A plus D is equals to AD B plus C. This right side is Anante. But A, B, C, are in natural numbers, therefore they are commutative with respect to addition, of course, multiplication. Therefore, this can be written as CB, D plus A, this is DA, C plus B. But this is exactly same as saying that what? What is this? CD is related to AB, yes or no?
Yes, sir.
Yes. So symmetric. Is it trans 2? You know, A comma B is related to
Yes,
CD.
sir.
C comma D is related to E comma F. Question is, so what is this? AD B plus C is equals to, what is this?
BC
BC A plus D,
A plus D.
right? But we are working with natural numbers, all are natural numbers. Therefore, divide with AB, divide with BC here, means divide with ABCD. That means what? What you get? Here BC you are going to get. Here, what you get? AD.
AD.
Divide with ABCD. Because we are working with the natural numbers, we can divide with the ABCD. Right? So what you get? This is 1 by B, 1 by C. This is 1 by D, 1 by A. Right? Next, what you are going to get here? CF
CF
D plus
D
C
plus
is
C.
equal to
DE
B C
C
plus F.
plus F.
Again divide with the
A
DECF.
CDEF.
Okay. So C plus F is equals to CF. Therefore, 1 by D, 1 by DE, 1 by F, 1 by C. Right? Now what you do is just add them, these two equations. What you get? 1 by B, 1 by C, 1 by D, 1 by E is equals to 1 by D, 1 by A, 1 by F, 1 by C. So here DD, 1 by D, 1 by D cancel, 1 by C, 1 by C cancel. So what you get? 1 by B, 1 by E, 1 by A, 1 by F. But this is exactly B plus E into BE, A plus F into AF. Again by cross multiplication,
AF into B plus C.
plus C is equals to BE into,
B into A plus F.
but this is exactly same as saying what? AB is related to
FE.
EF. Right? So therefore it's same. So it is trans 2. క్వశ్చన్ ఈస్ ఇక్కడ యాక్చువల్ గా నేను ఎందుకు ఇట్లా చేశాను, ఇక్కడ డివిజన్ పాసిబుల్ అవుతుంది కదా. డివిజన్ ఎందుకు పాసిబుల్ అవుతుంది అంటే ఇక్కడ డివిజన్ నేను ఏబిసిడితో చేశాను డివిజన్, ఎందుకంటే న్యాచురల్ నెంబర్స్ తో వర్క్ చేస్తున్నా కాబట్టి. న్యాచురల్ నెంబర్స్ కాకుండా ఇక్కడ నేను ఇంటీజర్స్ పెట్టిన అనుకోండి, ఇప్పుడు ట్రూ అయితే ఇక్కడ ఇదే ప్రాబ్లం, కొంత స్లైడ్ చేంజ్ చేసిన అనుకోండి, ఇంటీజర్స్ పెట్టాను, ఇది ట్రూ అవుతా, ఇది ఈక్వలెన్స్ రిలేషన్ అవుతా మరి. AD B plus C is equals to BC A plus D. సో మీరు క్లియర్ గా ప్రూఫ్ అబ్జర్వ్ చేస్తే యాక్చువల్ గా రిఫ్లెక్స్ ఎట్లాంటి ప్రాబ్లం లేదు, ఎందుకంటే నేను ఎట్లాంటి డివిజన్ చేయలేదు కదా, కాబట్టి రిఫ్లెక్స్ ట్రూ అవుతుంది. గో త్రూ ద ప్రూఫ్. ఓకే, వన్స్ యూ గో త్రూ ద ప్రూఫ్ యూ అండర్స్టాండ్ దట్ ఐఎమ్ నాట్ డివైడింగ్ ఎనీథింగ్ కదా, జస్ట్ యూజింగ్ జస్ట్ క్యాల్కులేషన్ అడిషన్ అండ్ మల్టిప్లికేషన్, దట్స్ ఇట్. సిమెట్రిక్ వచ్చినప్పుడే ప్రాబ్లం వస్తుంది కదా, సిమెట్రిక్ వచ్చినప్పుడే ప్రాబ్లం వస్తుంది, సిమెట్రిక్ వచ్చినప్పుడే ప్రాబ్లం అవుతుంది కదా. సిమెట్రిక్ కూడా ప్రాబ్లం ఏం లేదు, ట్రాన్సిటివ్ లో డివిజన్ చేస్తున్నాం కాబట్టి ట్రాన్సిటివ్ లో ప్రాబ్లం అవుతుంది. సో సిమెట్రిక్ కూడా ఆటోమేటిక్ అయిపోతుంది ఇంటీజర్స్లలో. బట్ ట్రాన్సిటివ్ అయిద్దా, రిఫ్లెక్సివ్ అవుతుంది ఇక్కడ, ఎందుకు ప్రాబ్లం లేదు కాబట్టి. సిమెట్రిక్ కూడా అయితే సేమ్ ప్రూఫ్ జస్ట్ ఏబిసిడి రాయడం అంతే. ట్రాన్సిటివ్ అయిద్దా, ఇస్ ఇట్ ట్రాన్సిటివ్?
No sir, negative elements ఉంటాయి.
నెగటివ్ ఉంటే we need to give a counter.
1/0.
సో నేను ఏం చేస్తానంటే 1 2 తీసుకుంటాను, 0 0 తీసుకుంటాను, 3 4 తీసుకుంటాను. క్వశ్చన్ is it related to this?
No.
Yes, right. 1 into 0 0 is equals to 2 into 0 into 1 plus 0. Yes or no? You know, this is 0, this is 0. Therefore 1 comma 2 is related to 0 comma 0. Yes or no?
Yes sir.
Yes. Question is it related to this? Yes.
Yes.
Yes, right?
Yes.
0
Yes.
4 0 0 plus
Yes.
3. Next 0 into 3 0 0 plus 4.
Identity with the
Question is, are they related? Are they related?
No.
So 1 into 4 4, 2 plus 3 6 4s are 24. This is one way round. What is the second way round? 2 into 3 means 6 into 1 plus 4. What is this? What is this? 30.
30.
Question is, are they equal?
No.
No. So therefore, this cannot be related to 3, 4.
It is not transitive.
యా ప్రాబ్లం ఇక్కడ మనం ప్రూఫ్ లో మనం అబ్జర్వ్ చేస్తే ఇక్కడ ప్రాబ్లం ఎందుకు డివిజన్ చేయాలి అనేది ఇప్పుడు మీకు అర్థమైంది. డివిజన్ చేస్తేనే ఇది పాసిబుల్ అవుతుంది. డివిజన్ ఎక్కడ పాసిబుల్ అవుతుంది మరి? ఇంటీజర్ లో పాసిబుల్ అవుతుందా? 0తో వచ్చినప్పుడు ఏమైంది? ఈ B0 C0 కానీ ఏదైనా ఒకటి వచ్చినప్పుడు ఏమవుతుంది? పాసిబుల్ కాదు. సో కాబట్టి డివిజన్ పాసిబుల్ కాదు కాబట్టి ఇంటీజర్స్ వల్ల ఫెయిల్ అవుతుందని ఫస్ట్ గెస్ చేయాలి. సో 0 వచ్చేటట్టు మనం ప్రూఫ్ ని సెట్ చేయాలి. సో దట్ ఈస్ వాట్ బేసిక్ ఐడియా. ఓకే, సో ఇది ఎక్సర్సైజ్ చేయండి. సేమ్ ప్రూఫ్ నేను చేయట్లేదు, మీరు చేయండి. ఓకే, A, B is related to C, D if and only if A plus D is equals to B plus C. Either check చేయండి. This is my first relation. Second relation, A, B is related to C, D. Question is AD is equals to BC. Either check చేయండి. Equivalence relation either check చేయండి. ఇది కూడా equivalence relation either check చేయండి. Okay, so these two are exercises. Next is counting principles. We have seen actually the coordinate of A is M, or you can take N. What is the number of, what is the coordinate of A cross A? That is coordinate of A into coordinate of A, n square. Question is, how many relations on A?
2 power n square.
2 power n square. We have seen already. Number of relations from A to B is nothing but 2 power mn. Here A is nothing but what? I require to have a relation from A to A. Therefore, these are n elements. These are n elements. So total number of relations
2
on
power
A.
n square.
So therefore, number of relations on A is nothing but what? 2 power
2
n square.
power n.
Question is number of reflexive relations. Number of reflexive relations on a set A, right? So what is the formula?
2 power n into n plus 1 by 2.
2 power n into
N plus 1 by 2.
that's it.
Average.
So actually, to take this AN, this A1, A2, AN. This is my set. Suppose you take A is my set, which coordinate is n. So this is A1, A1. This is A1, A2. These are my order pairs. This is A1, n. This is A21, A2, A1. This is A2, 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 AN. Going on like this. AN1, AN, A1, AN, A2. Going on AN. So for reflexive, I need to have this
diagonal elements.
So I need to have this, these elements in the relation. You compulsory relations lo undali. Even reflexive అవ్వాలంటే ఏం కావాలి? ఈ కంపల్సరీ ఉండాలి. మిగతా గురించి మనకు సంబంధం లేదు, కానీ ఇవైతే పక్కా ఉండాలి. ఓకే, ఈ పక్కా ఉండాలి కాబట్టి దిస్ కెన్ బి డన్ ఇన్ వన్ వే, రైట్? ఈ ఎలిమెంట్ ఉంటే ఉండొచ్చు, లేకపోతే లేదు, నాకు సంబంధం లేదు. ఐ డోంట్ రిక్వైర్ దిస్. అండర్స్టాండ్? ఐ డోంట్ రిక్వైర్. ఉంటే ఉండొచ్చు, లేకపోతే లేదు. సో ఎనీ పాసిబిలిటీస్ 2. ఏ ఎలిమెంట్ కూడా ఉంటే ఉండొచ్చు, లేకపోతే లేదు, నాకు సంబంధం లేదు. ఉన్న ప్రాబ్లం లేదు, లేకుండా ప్రాబ్లం లేదు. రిఫ్లెక్స్కి ఎట్లాంటి ప్రాబ్లం ఉండదు, ఎందుకంటే కంపల్సరీ ఇవైతే ఉండాలి. సో దిస్ కెన్ బి డన్ ఇన్ వన్ వే. సో ఇట్లాంటి ఎలిమెంట్స్ ఎన్ని ఉంటాయి? సో అప్పర్ ట్రయాంగిల్లో ఎన్ని ఎలిమెంట్స్ ఉంటాయి? అప్పర్ ట్రయాంగిల్ ఎన్ని ఉంటాయి? సో వాట్ ఈస్ దిస్? 1 2 3 అప్ టు వాట్ ఈస్ దిస్? ఎన్ని ఉంటాయా? డయాగోనల్ ఎలిమెంట్స్ ఎన్ని? మొత్తం టోటల్ ఎలిమెంట్స్ ఎన్ని?
n square.
n square.
టోటల్ ఎలిమెంట్స్ ఎన్ని? n
n
square.
square.
డయాగోనల్ ఎలిమెంట్స్ ఎన్ని? డయాగోనల్ ఎన్ని?
n
నాన్ డయాగోనల్ ఎన్ని?
2 power n square minus n.
యా, నాన్ డయాగోనల్ ఎన్ని? n square minus n. డయాగోనల్ n. టోటల్ ఎన్ని? n square. మనకు ఉన్నాయి ఎన్ని పాసిబిలిటీస్ ఉన్నాయి? మొత్తం ఎన్ని ఉన్నాయి? ఇట్లాంటి 2s ఎన్ని వస్తాయి? ఇట్లా 2s ఎన్ని వస్తాయి? ఇక్కడ వస్తాయి, ఇక్కడ వస్తాయి, ఇక్కడ వస్తాయి, ఇవన్నీ వస్తాయి. ఇవన్నీ 2s వస్తాయి. ఎన్ని 2s వస్తాయి?
n square minus n.
Power n square minus n.
యా రైట్. సో ఏమొస్తుంది ఆన్సర్?
Two to the power of n square minus n.
ఇప్పుడు ఫార్ములా ఏంటి? ఇప్పుడు ఫార్ములా ఏంటండి?
2 power n square minus n.
So n square minus n. Okay, number of reflexive relations should be like this. So కాబట్టి దీంతో ప్రాబ్లం ఏంటంటే a1 a2 తో a1 తో కంపల్సరీ ఉండాలి, a2 కంపల్సరీ ఉండాలి, a3 కంపల్సరీ ఉండాలి, an కంపల్సరీ ఉండాలి. So this can be done in one way. Remaining rest of the elements, how many rest of the elements? N square minus 1 n. So rest of the elements can be done in 2 into 2 into 2 into 2 into 2 into 2 into up to n square minus n times. So therefore the answer is 2 power n square minus n. Question is, how many total number of non-reflexive relations? Non-reflexive. Anybody?
N square
N square minus total minus reflexive.
n to n square minus 2 power.
Right? Next. Question is total number of symmetric. Anybody?
n 2 power summation n.
2 power summation n.
So I don't know the formula. This is stupid. So what you do is again this a1 a2
Sir,
a1.
can you explain how we get the reflexive relations, number of reflexive relations?
So that's what I told, right? So ikkada reflexive ante enti first.
Sir, please talk in English.
So reflexive ante, what do you mean by reflexive? Reflexive is nothing but what? Any element that is related to itself. Any element is related to itself. So in order to define a reflexive, what I require? How many elements did I take here? N elements. So to define reflexive, a1 is related to a is there. Therefore a1 comma a1 should be presented in the relation. Whatever relation you take, a1 a2 should be there in order to define a reflexive. Similarly a2 also there to define a reflexive. Similarly, how many elements? N elements. Right? Therefore there is no relaxation on these elements. There is no relaxation. Yes or no? To define a reflexive, I need to present these elements must in the R. Yes or no? There is no relaxation for these elements. So this work can be done in one way. Understand? You compulsory undali kabatti this element must be presented there kabatti automatically this work can be done in one way. Inka rest of the n untayi. So total number of elements n square. Total number of elements n square, n into n means n square. Diagonal elements n. So non-diagonal elements, how many non-diagonal elements are there? These are all non-diagonal. This, all are non-diagonal. How many non-diagonals are there? N square minus 1. So this element can be filled or not filled. There is a relaxation. Not necessary to fill in R. Not necessarily to fill in R to get a reflexive. So there are.
Sir, can you explain about?
Similarly, a1 a3 you can fill or not fill. It can be filled or not filled. So there are two choices, right? For a1 a4, of course two choices. For a1n, of course two choices. Next a21, two choices. A23, two choices. A2n, two choices. A31, three choices, two choices. A32, two choices. A34, two choices. Next ann. Itlanti 2s enuntay. How many 2s are there? Non-diagonal entries. Non-diagonal
4 n square minus n.
This is what actually formula.
Sir, number of non-reflexive, sir.
Non-reflexive n square minus 2n. See, total relations minus reflexive. That's it.
2 to the power of n square, not total relation.
Oh, sorry.
Total is n
2 power n square. 2 power n square minus total relations minus reflexive. That's it. Okay. So therefore, how many symmetric here? You look at the proof again. A2 a1, A2 2, going on. A2n, going on. An1. AN, A1, AN, A2, going on AN, AN. So we actually need to feel related to B. See, actually, I assume that R is a reflex symmetry relation. I need to count how many number of symmetric relations are a set. Understand? I assume that R is a symmetric relation. I need to count how many R's are there, how many symmetric relations are there. So to get a symmetric relation, first you need to fix A related to B. A related to B is there. You need to fix A related to B. Automatically B is related to A is there. So to get a symmetric, I bother about only this entries. Understand? See, first of all, how many ways this can be filled?
N square.
2 ways. How many ways?
N square. 2 ways.
So 2 ways. How many ways this can be filled? 2 ways. How many ways this can be filled? 2 ways. If దీంతో problem ఉండదు. దీంతో problem ఉండదు. A11, A22. So going on ANN. దీంతో ఎట్లాంటి problem ఉండదు. Understand? ఇది ఉంటే ఉండని లేకపోతే లేదు. కాబట్టి therefore this can be filled in 2 ways. ఇది రిలేషన్ లో ఉండొచ్చు ఉండకపోవచ్చు మనకు సంబంధం లేదు. But to define a reflexive, definitely that should be presented in the reflexive relation. The element should be presented in the R. But రిఫ్లెక్స్ సిమెట్రిక్ కావాలంటే మాత్రం ఇవి ఉంటే ఉండని లేకపోతే లేదు. మన R లో ఉంటే ఉండొచ్చు లేకపోతే లేదు. సో కాబట్టి ఎన్ని చాయిసెస్ ఉంటాయి? 2 చాయిసెస్. దిస్ ఎలిమెంట్, దిస్ ఎలిమెంట్, దిస్ ఎలిమెంట్, దిస్ ఎలిమెంట్. హౌ మెనీ ఎలిమెంట్స్? డయాగనల్ ఎలిమెంట్స్ n ఎంట్రీస్. సో 2 పవర్ n. మెల్ల రెస్ట్ ఆఫ్ దెమ్ ఎట్లా చూస్తారు? మనం A1 A2 నన్న ఫిల్ చేయండి లేకపోతే A2 A1 అన్న ఫిల్ చేయండి. నేను బిలో డయాగనల్స్ ఫిల్ చేస్తాను. ఆటోమేటిక్ అబౌవ్ డయాగనల్స్ నుంచి మనకు సంబంధం లేదు. నన్ ఆఫ్ ద బిజినెస్. యూ నీడ్ టు ఫిల్ ద బిలో డయాగనల్ ఎలిమెంట్స్. ఇఫ్ యూ ఫిల్ ద బిలో డయాగనల్, automatically rest of the above diagonals are filled by the same elements, because I need to have a symmetric relation. If you fill the below diagonals, automatically above diagonals can be filled by that elements only, because I require symmetric relations. So it's enough to fill these low diagonal elements. See, about the total diagonal, non-diagonals n untai?
N square minus n.
2 power n square.
Non-diagonals are n square minus n. So sagam n untai?
By 2.
N square n by 2.
By 2. So ఒక్కొక్క దానికి ఎన్ని రకాలు ఫిల్ చేయొచ్చు? 2 ways.
2 ways.
2 ways. అట్లాంటి ఎన్ని ఉంటాయి నాన్ డయాగనల్స్?
N square minus n.
నో మనకు కావాల్సింది ఫిల్ చేయాల్సింది ఏంటి? ఓన్లీ బిలో డయాగనల్స్. ఎన్ని ఉంటాయి అట్లాంటి?
N square minus n by 2.
యా, n స్క్వేర్ మైనస్ అట్లాంటి ఎన్ని ఉంటాయి? అట్లాంటి ఎన్ని ఉంటాయి అమ్మా? n స్క్వేర్ మైనస్
n by 2.
Therefore total 2n into 2 power n square minus n by 2. That means what? 2 power n plus n square minus n by 2. Therefore 2 power n into n plus 1 by 2. Right? So therefore this is what actually number of symmetric relations. Right? But బాధ చేయాల్సింది ఏంటంటే, నువ్వు ఫిల్ చేస్తే బిలో డయాగనల్ ఫిల్ చేయండి లేకపోతే అబౌవ్ డయాగనల్ ఫిల్ చేయండి. బిలో డయాగనల్ ఫిల్ చేస్తే ఆటోమేటిక్ అబౌవ్ డయాగనల్ ఫిల్ చేసినట్టే. ఎందుకంటే నేను తీసుకోవాల్సింది ఏంటి? సిమెట్రిక్. సిమెట్రిక్ లో నువ్వు ఏబీని ఫిల్ చేసినావంటే బిఏ ఆటోమేటిక్ ఉన్నట్టే. ఇక్కడ నువ్వు ఫిల్ చేయాల్సిన అవసరం లేదు. ఇక్కడ A1 A2 ఉందంటే A2 A1 ఉన్నట్టే. ఇక్కడ A2 A1 ఉందంటే ఇక్కడ A1 A2 ఉన్నట్టే. ఇక్కడ A3 A1 ఉందంటే ఈ పైన A1 3 ఉన్నట్టే. నువ్వు ఫిల్ చేయాల్సిన అవసరం లేదు. A3 2 ఇక్కడ ఉందంటే ఆటోమేటిక్ A2 3 ఉన్నట్టే ఇక్కడ ఉన్నట్టే. నువ్వు ఫిల్ చేయాల్సిన అవసరం లేదు. కాబట్టి నువ్వు ఫిల్ చేయాల్సింది ఏంది? ఫిల్ చేస్తే లోవర్ డయాగనల్ ఫిల్ చేయాలి లేకపోతే అప్పర్ డయాగనల్ ఫిల్ చేయి, సరిపోతుంది. రైట్? సో దెర్ ఇస్ నో సచ్ ఎ ఫార్ములా ఫర్ trans 2. నో ఫార్ములా ఇస్ దేర్. But there is a research paper on trans 2. So no formula for trans 2. Suitable formula, closed formula. No closed formula is there. For trans 2. Next. So we have seen what you have seen. We have seen actually reflexive, symmetric, and trans. So can you write number of equivalence relations? Equivalence relations. Yeah.
We cannot.
Coordinate of A is n. So to define a number of equivalence relation, it's enough to know the number of partitions of n. You know partitions in group theory, elementary number theory. I think we'll see in next couple of classes what may be partitions. So suppose my coordinate is 1, means you can take A set, singleton set. How many partitions are there? This can be represented in one way. So therefore partition of 1 is nothing but what? 1 only. Suppose a set has 2 elements. How many partitions are there? It can be represented by like this or AB. This is a partition. This is also partition. How many partitions are there? Itla rayachu, itla rayachu. Itla rasna em kaadu, itla rasna em kaadu. How many partitions? 2 partitions. Right? Suppose n equals to 3 is there. How many partitions? ABC rayachu. Ingem rayachu? A, BC, idoka partition. Next B, BA, idoka partition. Next C, AB. Right? Itla rayachu. Inga itla rayachu. Inga itla rayachu.
No, sir.
Is there any possibility? So 1, 2, 3, 4. Inget lan rayachu, singletons rayachu kada. Inno rayachu 3 rayachu, 2 plus 1 rayachu, 1 plus 1 plus 1. Singletons rayachu kada, ABC. So inno total 1, 2, 3, 4, 3, 4, 5. Idokati partition. Understand? Idoka partition. Idoka partition. Idoka partition. Partition ante entama. What is meant by partition? Class of sets. What do you mean by partition? Class of sets. Class of subsets. Make a number of class of subsets of X is nothing but what? Partition if and only if any 2 distinct members are disjoint. Right? If you take the union over the sets, should be total X. You take the union of all members in a script A. If you get total X is nothing but what? If the class of subsets of X satisfying these 2 properties, we can say that is a partition. You can observe cheste the total union cheste malli vastadi ee set itself is what is that? There is no distinct set aithe ledu. Distinct set unte empty kavali. Okate set undi kabatti disjointness prove cheyalsina avasaram ledu. Union cheste full X kavali. Ikkada full X ante enti A ravali. Ikkada chudandi A undi BC undi. Ee rendu disjoint aithe union cheste
Total set.
total set. So partition aithe. కాబట్టి ఈ సెట్ ఏమైతే పార్టిషన్ అవుతుంది, ఈ సెట్ పార్టిషన్ అవుతుంది. బీసీ ఉంది అనుకోండి, బి అండ్ ఏసీ ఉంది అనుకోండి, ఇది పార్టిషన్ ఇద్దాం, డిస్జాయింట్ ఉన్నది, టోటల్ యూనియన్ చేస్తే ఏబిసి. సో ఇది కూడా పార్టిషన్. సో ఇది కూడా పార్టిషన్ మీకు వస్తుంది నెక్స్ట్ కామన్ ఎలిమెంటరీ నెంబర్ థియరీ. సో దర్ఫోర్ ఇది ఆల్సో పార్టిషన్. సో ఎన్ని పార్టిషన్స్ ఉన్నాయి?
Partitions.
సో కాబట్టి ఈక్వలెన్స్ క్లాసెస్ ఎన్ని ఉంటాయి అంటే పార్టిషన్స్ ఆఫ్ ఎన్ అన్నమాట. The formula. Okay. Next is function. Okay, this is what about a relation and number of relations and number of reflexive, number of symmetric and number of equivalence relations. Right, next is function. What do you mean by function? Suppose A and B are 2 non-empty sets. We take any relation from A to B, we call F for sake of our convenience. We take any relation. What is my F? F is a relation from A to B. That means you need to write it. F is a relation from A to B.
Each element of A has exactly 1 element of B.
So to say F is a function, F is a function from
unique image.
Every element that you take in A has a
unique image in B.
Under the relation F. Under the relation F.
F.
Of A as a unique relation in B under F. That means any element that you take A, for every element A in A, there is this unique element in such a way that f of A equals to
A related to
B. Right? If that happens, one can say that f is a function. F is a function. There is no right? There is no, what is this? There is no rest of the pieces in A. All the elements should be related. No element is, leave this. Understand? No element is relaxation. No element is relaxed. Every element is mapped, and every element is mapped to unique element. Understand? For example, let us start this. Suppose you take this A equals to 1, 2. B equals to AB. Suppose my F is 1A, 1B. Is it a relation?
No, sir.
Relation, but
No,
not.
sir. It is not a
Relation.
function.
Relation but not
It is a
function.
relation but not
No,
function.
because it's a subset of A cross B. Therefore, it's a relation from A. Question is it a function?
No, sir.
No,
No,
sir.
sir.
And one has a two
No,
images,
sir.
so it is not a.
One has two images.
In set A, 2 is
One has two images. Therefore, it is not a function. It's a relation, but not a function. From A to B. Right? Suppose you take this, F is equals to 1A. That's it. 1A enough. Okay. Student name it 1A. Only 1A. Is it a relation?
not
Yes.
a function.
Relation, but not a function.
Yes, relation.
Question is it a function?
No, sir.
No, not a function.
One is related to A, one is mapped to A itself. Okay. But the two element is
Two element.
no element of B is mapped to 2, right? So therefore 2 has no images. 2 has no, in particular, has no images. 2 is not related to any element of B. In fact, 2 is not related to any element of B. Therefore, 2 is missed. For 2
This is
elements,
not a function.
therefore F is not a function. From A to B. Why? Why? Because 2 is
No
not related.
image.
2 is not related to. Why this is true? 2 is not related to. 2 is not related to any B. Okay, so relation is first of all. Unique tarawata. Okay. Suppose 1 2B. Yeah, is it a function?
Yes, sir.
1 2 AB.
It is a function.
It is a
1 has images, it is unique. 2 has image, it is unique. Therefore, it's a function. Suppose 1 2 1A 2A 1B. Is it a function?
No, sir. No, it is not a function.
Therefore, 1
And it
has,
too has the same
1 goes
image.
to A and 1 goes to B. 2 goes to A. So 1 has two images. So there is a V shape is there. Whenever V shape is there, it's not a function. So 1 has two images. 1 goes to A, 1 goes to B. Therefore, it's not a function. Right? So whenever F is a function from A to B, we say that A is a domain of the function. Here B is nothing but what?
Codomain of the function.
Here the elements, the images of a function is nothing but what?
Order of B.
Image of the function.
Range.
Right? Means image or range.
Range of
The function. Right? So domain of the function, codomain of function, range of function. Domain is nothing but A itself. Codomain is B itself. That means this is my A, this is my B. Whenever F is a function, A is a domain. This is my F of A. This is range. Range of the function. This is what codomain. B is nothing but codomain. A is what? Domain of the function. What is my A? A is my domain of the function.
domain.
Right? Yeah, now tell me. Suppose you take this. Is it a function?
Yes, sir.
Yes, correct. So
Sir.
what you do is simply, this is my parabola because it's symmetric about x, y-axis because x square is there. So what you do, simple technique is draw a line parallel to y-axis. If it meets exactly one point, it's a function because every element that has a unique image. This has a unique image. Draw a line parallel to y-axis. If it meets exactly one point, we can say that it's a function. So clearly it's a function, no doubt. Any line parallel to y-axis, if it meets exactly one point, at most one point, then one can say that this relation is a function. Suppose you take this. Suppose you can take this graph. Suppose you can take set of all order pairs such that y square is equal to x. Is it a function? Set of all order pairs. What is meant by function?
No, no, sir.
No, sir.
It is
No,
symmetric.
sir.
It's defined on R.
You take any element which is in F. Take any element that is in F. That means y square is equal to x. That means it's a parabola which is symmetric about x-axis. So draw any line parallel to x-axis. You know it meets 2 points. Therefore, for this element has two images. One is this. One is this. So one image is this. One image is this. This is my A image. This is my B image for the same element. So therefore, it is not a function. And suppose you take this. This is my relation set of all order pairs in a plane such that x square by a square. Take this and fixed a point. So x square by 4, y square by, suppose you can take x square by 9, y square by 4, 1. So thing is it a function? What is
No, sir.
any element? Yes. That means it's a point on ellipse. It's a point on ellipse.
Ellipse, sir.
Therefore, it is a point on ellipse. So therefore, draw any line parallel to axis. It meets 2 points. Therefore, it's not a function. It's not a function. Yes or no? Right? Now my counting principle. Suppose my coordinate of A is m, my coordinate of B is n, right? Now my question is number of functions from A to B.
Order of B power order of A.
Right? Suppose you have a coordinate of A is m, my coordinate of B is n. So total number of functions. What is the total number of functions? So just to get this answer, we need to apply the probability and statistic techniques, permutations, combinations. Let us go through it. So I need to have each element as a unique image under the relation F. So for A element, there are n options. How many options? For A element, it can be related to B1, it can be related to B2, it can be related to B3, it can be related to B4, it can be related to Bn. So for A element, it has n choices. For A2 element, of course, it has a n choices. It can be related to AB1, it can be A2 can be related to B2, A2 can be related to B3. So it has a also
n power of m.
Thing is the work completed? No. నేను ఫిల్ చేయాలంటే ఫంక్షన్ కావాలంటే ఏంటి A1 A2 ని ఫిల్ చేస్తే చాలదు. నాకు ఎవ్రీ ఎలిమెంట్ కి ఇమేజ్ ఉండాలి. వర్క్ కంప్లీట్ కాలేదు. Till the work is not completed. And go through the A3. Go through A3 and A3 has n options. Therefore A3 can be related to in n ways. Therefore it can be done in n ways till the work is not completed because there are A4, A5, A6, A7. Similarly, A4 can be done in n ways. A3, A5 also can be done in n ways. Similarly, going on, AM can be done in n ways. Therefore, the total work is done. So if the work is done in n ways into n ways into n ways, n ways, n ways, n ways, n ways, therefore by product rule, this can be written as n into n into n into n into n ways. How many n's? How many n's?
M power n.
So therefore, this is nothing but n power n. So therefore, total number of functions, that is nothing but what? N power n. That is nothing but what? Coordinate of B whole power coordinate of A. Right? This is true for only finite sets. This formula is work for only finite sets. Suppose you can have coordinate of A is equals to 3, coordinate of B is equals to 4. Total number of functions from A to B. What is this?
4 power 3.
4 power 3.
Now number of relations which are not functions. From A to B. Yeah. Relations kavali, functions kavali. How many relations?
mn minus.
How many relations first? What is A cross B? Coordinate 3 into 4. 12 elements. How many relations? 2 power
2 power 12 minus
12.
64, sir.
Total relations 2 power 12, because number of subsets of A cross B is nothing but 2 power 12. So total number of relations is nothing but 2 power 12 minus functions. How many functions? 4 cube. Right? So total number of relations are nothing but what? 2 power 12 minus 4 power 3. Right? So this is about functions. Right? But tomorrow I'm going to start 1 and onto functions and classification of functions.